Okay, where's the rest of you? Mana yang lain semua? Berapa orang yang ada ni? Alright, class, I cannot wait for the others. So we start. Okay, for today, this week, we just focus on our project. Project, I think I already informed you to form a group. I believe already shared in the WhatsApp. You already have group. Tak ada issue kan? Semua everybody have group, right?
Yes, sudah
Semua ada
form.
group. Right. And everybody kita have tak ada isu apa-apa on the group. Nanti I don't want the last minute one student mention that I don't have group, nanti dah terlambat lah. Kalau any issue, do it now. Do it now, mention now. Kalau you tak ada group. Minimum is 3, maximum 4. So I think I did mention last week about your project ni, you have to provide me some sketching. Do you have any sketching for your project? Ada? Class.
Sorry, Doctor.
Last week, I think I did mention kan, I would expect you guys to show me at least one sketch of your project, your concept
Yes,
ideas.
Mention
Ada,
already, Doctor.
ada Ijian, ada.
Yes,
Alright.
Doctor.
Do you want to share? Boleh share ke? Is it possible you share ini? Because this week kita focus on project. Okay, okay, Yijian, but kalau you share, okay, hold on, you try find any sketches you can share while you are trying to share. Let me explain to you about our project, major project ni. If you look on your,
Doctor, is it mean necessary to sketching because actually we found our my group lah, actually we only found from the Google there is some something like sketching lah, because there's only a rebuild and then connect to the motor and a gear, can I say like that? And then that gear one and will connect to a shaft, and then that shaft will connect to the thing, that machine, and that all.
okay, to answer your question, Yijian, yeah, it's a must. Sketching is a must because whatever things when we do, we need to plan. Because any concept ideas you need to discuss with your group members. Because when you are doing a design project, especially design a machine, actually we have to go through design process, like you have learned in introduction to design during your first year. But in this component design, we don't have to, you have to go through design process. But we just shortcut because our main content of our course here is component design. We focus on engineering analysis. By the way, in this course, we have project which carry, I think, 20% of your total point. Project, I mean, you have to design a machine, been given title given by the lecturer. Since the title that I give to you is food mixer. So you and the group, I just give a general title. You find it yourself. So you and your group, each group have to be independent, have to make a research, make a research, background studies on what type. Okay, first you make a background studies research. You need to kind like look at the real situation that industry. I know, I understand we are online now. You are not go out, You are not going out to find information. It's better you visit the industries, the food industry, then you know the situation. But you can create something like the situation. You focus and try to make a research in the internet or whatever you can. What type of possibilities of food mixer that you're going to focus? That's why we need to plan first. We not just simply, okay, Ijan, you told me that you just, okay, you said you just have VBAP and pulley and okay, just to rotate the output drum, something like that. But actually, yeah, that one is part of research. Okay, tapi it's not quite proper. To make it proper, you have to make a little bit thorough studies, have to make deep studies of what type of food industry you need to focus. Because, for example, if you want to focus, let's say you create a situation that who will be your client. The client, I mean the person or the or company who buy your machine. So what type of food that you want to mix? For example, like if your client is just a medium scale or small scale industry, macam for example perusahaan makanan di kampung-kampung or any agency kan, Jabatan Pertanian or any medium scale industry that process kerepek ubi, like for example bijirin or maybe like what type of food industry do you want to mix? Kalau if that kind of food, for example, just mixing the flour tepung flour ni is tepung kalau American pronounce flour tepung and mix with water. If your mixing food is just doing that, just for a small scale industries, and your machine don't have to be really high efficient. I mean efficiency, your expectation is really high efficient, accurate machine, precise machine. What I mean is precise machine. If you need precise machine, food mixer machine need to be precise. So you might discuss. That's why what you have learned before, I already mentioned during our lectures, right? If your machine need to be so precise, I mean you do a survey first to make, okay, for food industry, for example, first I want to explain that kalau if your machine just mixing, rotating drum and mixing, but you need to identify what type of food, because I just mentioned food mixing machine, so we need to you need to focus, you discuss with your group what type of food mixer machine that you're going to do. You not just simply you select belt and pulley, then sit and we shaft and you rotate. So we need to plan first. Actually design like that. You go there, find make a background studies. What type? Then you decide. You search information first. then you discuss with your group. Then you make decision what type of food mixer machine that you're going to do. Because if we are talking about food mixer, we have a lot of category of food. We have liquid food, we have granulars, biji granulars, or we have semi-liquid, or maybe we want to mix from flour plus water. At the end, it will rotate, mix, and at the end it become dough. At the end, it will become dough. That time of mixing, because first it's kind of like liquid and powder, right? But at the end of the process, they make at the through times, then it become a dough, then becomes semi solid lah. Dough kind like ni. Dough punya kind of material. It kind like not normal in liquid form. It's more like in between liquid and solid form. Dough it become, so the density increase, kelikatan and so on. So okay, if that kind of mixer, you need to discuss with your group member what type of component that should be in your output shaft, what type of the mixing blade. So what is the power output That's why you study first. You study, make a ground study. So from there, then you can decide. And from there, you can decide. Okay, for this kind of machine, either do we use gears, spur gears, or do we use pulley and belts? Okay, like I mentioned to you, if you go for really constant velocity and high efficiency, and you really need the power to be really good, power input from the motor and the power output also not less power loss. You should go for spur gears. Spur gears, if you want your machine to be really precise, the rotation of RPM. So you need to study also. If you say that this is you want to mix food, okay, for example, like flour plus water, and then to mix, and at the end it become dough. Okay, this kind of thing you need to study in the internet. What is their, do they have two speed or they just one speed? Okay, if they have the only one speed they need for the drum, what is exactly the rotation of the drum, the output speed? What is the rotation? You're not just simply you select V-belt, no, you define dulu. So what type of food that you want to mix? Okay, maybe one of the group, other group may be doing different and focus on more like food industries, for example, like what we call it in bahasa Malaysia, kerepek, food, the mix. You have to make to be independent. Don't depend. I just give a general title only, food mixing machine, because there's a lot there. Food mixing, food industry, a lot type of food. We are not talking about the final food product, the way they are process they make the food. Maybe they mix something. They have a lot of it, maybe in powder form, maybe in liquid. Sometimes liquid form also we call food. Okay. And maybe in what we call it in biji granular. In granular form also is food mixing. So you need, like for example, coffee mixing, coffee beans, right? Coffee beans or something they need to mix. That also consider food industries. Any kind granular form. So what is the speed? What is the speed? Okay, if this kind of machine, for example, like you beans, I don't know, soya bean, anything, you have to make research. Soya bean or coffee bean or maybe corns, they need to mix. I don't know, because you know better. You are doing this. I only give the title. You have 4 of you or 3 of you. You have to be independent. So this week, focus on that. Focus on what of food mixing product that you want to do. Kelas, are you listening? Boleh dengar saya ke?
Boleh, Doctor. So for my group, actually, our focus is about dark machine lah, Doctor. To mix the flour, and then finally they can create the bread. And based on our research, I think that it is semi-liquid or something like non-Newton liquid, right? Because after you add the flour and then with the water and there's something like semi-liquid lah, and then you need to continue to mixing until there's certain level, and then you can pour out and then create the bread, something like that. You can go through the conveyor and then you can through the machine, not machine lah, through the something like cutting or whatever, and then the all can become the bread shape, and then they go to the next step, something like that. So for our group, for my group, actually, we just simply connect the sketching is very simple one lah. Just how I say, electronic DC motor connect to a gear, and then add a V belt connect to a shaft that is a mixing. That's all. But I draw very simple. Actually, our group haven't discussed what electronic DC power is required, how many RPM require, or something like that. We just simply draw only. Doctor, do you need to see or what?
Yeah, you can share it with us. I thought tadi you cakap earlier, you mentioned that I thought you just okay, you just decide you want to do door mixer and that's it, you want to use belt and pull. That's a wrong approach. Okay, what you said just now is good.
Kita cuma simply one drawing, tak cantik pun sebenarnya, tak ada.
No, tak. The way yang you find information tadi, yang the one you explain later, that one is okay. I satisfied with your so you discuss first and do not. I thought you said earlier just now, you just simply we want to use pulley and bezel. No, that is a wrong approach. Then only you decide what machine. No, so you make the research first. That's why you did this right. Make a research. Okay, you want to do. Okay, your machine is a door mixer, right? To make a
Yeah,
dough, right?
so
Mixing to make a dough. So your input will be flour and water, right? Am I right?
yes, correct, Doctor.
They will dump in. You don't focus on how the machine mechanism to dump in. No, that is that is not part of your scope. Because in the food industry, there's a production line. Maybe they have before your machine, they have a production line. They have amount of liquid and amount of powder that is beyond your scope of your machine. Your machine is just they will dump in amount of powder, flour, and water lah. That is beyond your machine will not consider how many amount container. That is manually done. Your machine is just focus on mixer. Okay, in production, maybe you have modular. You have modular. Your module is to mix it. So the output of your machine will be dough, right? Am I right? So you will mix. The put amount of water and flour. At the end, it will rotate it, and mix, and at the end will become dough. Am I right, Eugene?
Yes, Doctor. At the end,
Yeah. So you need to study if this kind of machine, how do we need one speed? Is it okay? Itu yang research I want you expect you to do. Is it one speed or two speed? I don't know. I'm asking you. You already done research. One speed or two speed? Or is it just maintain one speed? I think one speed, right? Yeah, I just guess lah. One speed. If it one speed, as long you pour in water and also flour, that amount, then it will do at the end, it will mix. Okay, if that kind of machine, what is the RPM? Have you decided? Itu yang I want you to do research. What is the RPM of that machine?
Doctor, I share the simply dropping lah, Doctor,
Okay, check.
in the group. I also can share the
Other group listen. Kita share this apa kita cakap, this information lah. So other group also have to take note on this. So the approach.
Doctor,
Yeah.
I also share the information that we found, my group found in the Google. It simply state that the dark machine only connected with electronic DC motor and the one shaft connect with the mixer. That's all only. So I believe there's based on what we found, that we believe that only single speed only lah. So I think we no need to have two type of gear or whatever.
Yeah, tak. Okay, forget dulu about your power transmission. Later on. Then you will decide either want to use seperti itu, later on nanti dulu. We are talking about the machine in general. Okay, what is the output speed? I need to know for this machine. Have you made a research? You need
Haven't
to
yet,
exact.
Doctor. Actually, we only decide until what
Ah.
type of the
Okay,
design that we want, Doctor.
Okay, your next step will be what is the exactly RPM they need for this? Because if you just simply machine and around is rotate, no, it will not works. Because to make a dough mixer to become a dough, they need a certain amount of speed. So you and your group have to be independent, make a research to make a dough. Exactly what's the speed? Okay, do research. Speed there, I think about, I don't know, I just guess. Let's say 52 RPM. We're not talking about 50. For example, previously I just guess 60 RPM. And no, actually no. You have to look in the internet. One way to do that is you can Eugene, are you going to share something? Okay, I continue on talking.
I thought I already share in the WhatsApp group lah, Doctor.
Tak boleh share sini ke? Share in this Webex.
Sama je, sebab yang satu atas tu adalah drawing, yang bawah tu adalah screenshot.
No,
Dapat dari Google.
share in this Webex. Share in this screen. Boleh tak? Can you
Terus
do that?
share yang picture tu
Can you do that?
Sekejap Doctor,
So everybody can see.
saya sharekan, Doctor.
Alright.
Doctor, I share already, Doctor.
Alright, okay. Okay, yeah, if you look on this is a sample product you look in the market, anything from China, this one, yeah, normally for a food mixer for to make a dough. So is it this one is a dough to make a dough? This machine, is it mixing mixer? They are trying to make a dough making machine.
Yes, we found the dough mixer for machine lah. Tapi is a very much pilihan lah sebab yang satu dia ada buat macam ni, yang lagi satu dia cuma 2 gear saja. So we think that this is more suitable and more maybe economy efficiency lah because they quite cheaper compared to the 2 gear, right?
Yeah, tapi be careful. Yeah, you are right. Yeah, what you said is right. But sometimes it depend on our normally design class. Tengok sini tengok sini class. Can you see my live video? What you did, your background is right. You study this part of your design process lah. First thing we have to make a background studies, right? Tapi sometimes can you create a situation? Can you see my live video tak? Kelas, boleh nampak live video saya? Hello kelas.
Yes, nampak tu.
Okay, sometimes in project you make a list. Okay, this one you look through sample product there in the market, but you don't know actually how much the capacity it will carry. I'm not talking about power capacity. I'm talking about capacity of the production performance of the machine capacity in term the volume volume flow rate. The performance of this machine. The performance of the machine is in terms of how many quantity of dough they will produce in terms of per minute. I'm not sure how they define it. Understand what I mean? Capacity of this machine, it can produce how many dough, how many liter of dough, for example, how many liter of, I'm not sure either liter dough, we're talking, if liquid, you call it liter, if granular, so we can call it liter, but if dough like between liquid and solid dough, is it in terms of gram dough or ni? So you need to be certain, or the spec, okay, the output speed, the performance of your machine, that's what we call the performance, the capacity in terms the volume per minute, the volume that you can produce. So that is quite also important, because sometimes, okay, so you can decide with your group. So because you don't know how much the size of your container of the mixer, you don't know. So we need to be kind like exact lah, because if we don't know, sometimes we make it maybe too small or too big. We don't know the exact size. Okay, to make that, to do it correctly, if that is the case, you try, you and your group member to focus in terms of volume capacity. If you sometimes we look on the analogy product, analogy product mean product that quite similar, like this one is similar product or exactly the same product in the market there. So look on the capacity of the volume of their dia punya tank tu, dia punya container. Okay, the first thing, what you should do sekarang ni, for all of you, not just a Yijan group, maybe you guys doing different, Yijan and the group doing for dough making machine. Maybe the other group can go for, I don't know, coffee bean plus beans. I don't know, beans, mixing beans, or maybe semi-liquid mixer. Go. Okay, sometimes in project and biasanya your customer, okay, for example, your customer is Nestle. Nestle is a big food industry, global, right? So Nestle, they have not the engineers though, they have food technologies, because Nestle, food technologies, they have a lot. Food technologies too. They will be dealing, you will be dealing with their food technologies, and because food technologies because Nestle, they want to maintain the good quality of their food mixer. Maybe they want to mix to become one of Nestle product, I don't know, maybe it could be in powder form, it could be in semi-liquid form, it could be maybe dough, I don't know, maybe Nestle produce kind of a dough for bakery, I don't know, under Nestle, or maybe different company, or for baking industry. You want to do for making donut. For example, look at what is the donut industries, in food industry, main player of donut. So they need this dough, maybe this dough with yeast, So you need to be exact lah. It's good like that because why I don't want, because I want you to look at it, you as engineering consultant is like that. Okay, from there, okay, you try to make, biasanya normally your customer, okay, for example, let's say is Nestle. Nestle want you to kind like maybe they want you to do their food mixing machine for their production line. Okay, for example, like for example, like Yijian, your case is a dough making machine, for example. Okay, your company is not necessarily like, okay, I changed it to something, a very famous baking company. So one of their production line, they want to make a donut, for example. Okay, one of it, they need to make your dough lah. Your dough to will become at the end, after your machine is one module. The next module of their production line is another process to make a donut lah. So your machine too is just to produce a dough, quantity of dough. Understand, Yijian, are you listening or not? I don't want you to make research, a lot of research. No, just a simple, I just want to create a scenario. Yijian, are you listening or not?
Yes, doctor.
Okay, for example, your punya production line is making a donut. Okay, pasal you need to identify, okay, main dough for what? Dough you can lot, dough for roti, for bread different, dough for donut different. Boleh tak you focus on one thing? Okay, maybe you punya dough making machine to, okay, for example, they want to make, let's say we focus on donut. Our dough machine does not produce donut. We just, our output of machine, as long you become dough. So the amount of dough is kind like enough to make their production. Okay, you create kind of station. So what my point is, your customer will ask you, okay, their production line, what is the capacity? Capacity of the volume that you punya, capacity of you punya machine. Capacity of your machine. Capacity of called performance, performance of your machine. Performance ni macam you when you design sport car, performance is your speed, speed, your fuel consumption. For example, this kind of machine, you punya capacity of performance is how much it can produce per minute. So from there, you can identify the size of your, then they will ask you, maybe your customer, because there is their production line, they have their zone. Because what I explained to you guys is just for you to guide you. Okay, they have some kind like size limitation. Because this is your machine. Okay, before your machine is dough making. It's a food mixing machine. Dough making machine, food mixing. We consider as category food mixing. Before your machine, they have another production line. Okay, they have production line A, production line B, and yours is C. C is dough making. Okay, maybe they are A. Before that is A. Maybe do it manually lah, and come to your place. Then go to another place. And maybe they have a kind of size limitation. Your machine too. Your client will ask you, okay, your machine will be mounted on their production line, and you punya occupying space. You punya occupying space. Limitation, size limitation. Occupying space is like this. This is the length, width, and height. So this will be the limitation of the size of your machine. Ini I bukan nak buat, I cakap you to explain the real scenario lah when you do design project. Occupying space. So can you, you and your group, Yijian, the other group also, you identify what is the occupying space of your ni. Because nanti kalau when you design nanti you simply, okay, you want to use, I want to use V-belt and pulley. We don't want to use spur gears. Tapi you haven't decided, you don't know what is your machine all about. You dah decide terlalu early. You decide too early about what is your power transmission. Hold on first. We want to know what type of machine. Okay, for example, Yijian, for example, you punya client is a bakery company. So maybe they will give you signal based on their punya engineer there, or maybe normally engineer lah. The engineer will inform the engineer of that baking company. This is a big baking company. Consult. You are engineering consultant. Will do automation, design machine from there. So the engineer there will cakap you the occupying space is not more than this, because they want to mount your machine to become in their production line. So my point is, can you guys, you look from, you don't know, sir, I don't know, we don't know the size. You can look from the internet about overall lah. Okay, to define the size, okay, you just guess lah. Maybe this one 1.2 meter, who knows, and this one 0.9 meter, this one is 1 meter height. That is you punya total volume lah. So it's good like that. So you know you punya what is you punya bounding box of your machine, you punya not more, to make sure that your machine will be not too small, and not too big. So this were your limitation size. So you try to occupy this space. Understand that, class? Class, are you listening or not?
Yes, Doctor. During Doctor discuss, actually, my group is go to find some information about the dark machine running speed lah. We found that different liter they have different mixing speed. For example, if there's a 5 meter, then the bitter process have 131 run per minute, something like that, Doctor.
Okay, you go for simple one. Go for one speed. I suggest that do not go for very speed. Because complicated, your color speed you have a speed apa? You have a
Doctor
special.
can check here the screen here. I share already the screen. Here is the specification, and Doctor can see that. Wait, Doctor can see that during 5 liter, if the container in 5 liter, then the mixing speed is about 131. Actually, we focus on one
Yeah,
picture
focus.
only lah. Because if we focus two, there's quite problem. There is a 152 for Wix process, and there is a 131 for bitter process. Then I believe that we need to use a lot of gear over there if you want to change the speed. So something like that, and the input power is 300 watts. So maybe we will go to try to find Alibaba to search the electronic.
You have a lot of various in terms of the model, right? So you need to focus on one. Which one you want to go for 5 liters?
Sorry, Doctor? Various mean the Wix process.
You have a lot of choice here. So you want select one. My point is select. So focus on one.
Okay.
Select one speed only. Okay.
But of course, the frequency, something like that, we don't care, right? We only care the input power and the mixing speed. And the bottom one is used for us to sketching, right? Something like that, Doctor.
Yeah, okay, right. So what about the size?
Size actually, I think it's 5.5 liter. Maybe we choose this one, the 5 liter one, and then the machine dimension should be 350, 230, and 400. I think this is enough for the commercial product lah, because it's sure here. It definitely mean that his product is like this, right? So we just follow him and we got a reference lah, something like that.
All right, okay. Okay, yeah, you are right. What you said, okay, this is part of your research lah. Okay, this model is already in the market. Okay, this model, okay, we have two category. Okay, I understand you can do it like this also. Okay, but sometimes in design consultant, okay, we are looking at make a research on the current product in the market for door mixer machine. Door mixer is there because they make it commercial. But what I'm explaining to you is not about commercial machine. What I explain to you is about more on your design, your punya custom design. Sometimes industry like that. Because industry, sometimes industry, they have automation in terms of production line. Because industry, as a design consultant, I'm talking you are doing design consultant. You are design consultant company. This kind of what you have learned from this course, you can apply it when you, after you graduate, become an engineering consultant. You and your friend make or form a company. This part of your work, doing automation. Okay, what I'm talking is more on custom design. Do you understand what I mean? What you do is right. Okay, you look on the current. What I'm talking, sometimes we can create this question. I'm talking about the real thing. But because in production line, info industry, sometimes we go macam industri kerepek. Industri memproses kerepek ubi. Contoh industri memproses jagung. Adalah yang makanan-makanan they put the sell in the market. Kerepek ubi. I mean, because they need machine. Normally, their workers doing labor and manual to do process. They need labor. Okay, this kind of customer, this company, they will hire a design consultant like you, like what I am explaining. So they want, okay, they will explain to you, okay, your machine, sometimes they give you their punya, even like big company also honestly, sometimes the machine you do is not based on what you, I mean, kalau if they're in the market, we simply buy, we don't have to do this. We can simply buy, but all the one more that, okay, what you did is good, you can do this as well. I didn't say, I have no argument on what you explain, Ijan. What I'm talking is the another story. So sometimes your customer will define, so your machine too will be a custom design. So your machine have to be your own build because you build your own power transmission. Okay, what you did is right. You look on the what is existing there. This company ni they is commercial lah. They already make this product for food industry. So this one they sell their product, this dough mixer to be mounted on ni lah. Any company want to buy lah, food industry company want to buy it, or even domestic.
So maybe in something like this, maybe we can follow the model because there's a 5 liter, 7 liter, 10 liter,
Yeah.
and there is a mixing speed and input power. Maybe we can follow these three things. If we use 5 liter, then we use input power 300 watt, and then the mixing speed is 131 run per minute. But the designing we based on our own scenario. Is it okay like that, Doctor?
Boleh. Okay. Another thing I'm talking, itulah, sometimes customer, when you do, the customer will give you what is the volume that you have a limitation of space. Okay, so it means you have to I make sure when you do your, because that's why I need to see all of the group punya sketching I want to see what is your punya overall size of your machine. That's the first thing, overall size of your machine. So sampai overall size of the machine, normally what we simply do it, so that we need to make research. What you did, Ijan, is right, one of it. What another story I talking about, sometime industry, customer requirement. This is what you got, your customer requirement. They'll ask you to do, okay, this machine about this size. Sometimes you have some, because if you just simply doing a machine, you make and you design it, sometimes is it sesuai ke? Is it suitable at the place there, at the, your client punya, your punya customer to mount under ni, maybe is it based on their production line. Sometimes like this, we look at their production line macam mana. Sometimes like this, they got certain, they give you the limitation in terms of space. So this would be your punya ni lah, you punya first constraint that you need to follow lah. Limitation that you need to obey this thing. So okay, my point is you make a sketch. Okay, once you know your overall size of your machine, okay, as a macam Yijan, okay, what you did is right, you look at example, maybe you guys also can look on the internet what type of a mixer. But if you don't have, macam Yijan, they have this thing. For example, you guys, kalau group lain jangan follow the same. Different group go for different, make it interesting, food mixer. Okay, kata you want to make beans, bean mixing machine, beans. I don't know, maybe coffee bean, what beans, I don't know, to make product. So you make a research on that, mixing, to do something, mix beans to make a powder. Kalau you cakap beans to become powder, that one is grinding machine. You must be careful. Either grinding machine, is it food mixing? To you kena justify. I'm talking about food mixing machine. So you have to, what type of food mixing lah? Okay. First, okay, you know your punya overall size of your machine. So you know, and then you will decide. Okay, Zijan, for example, okay, yours is dough mixer, right? Dough mixer. Okay, for example, dough mixer ni, kalau you punya if let's say kalau you make a research in the internet, the dough mixer tu, they really need to be, to make a dough, they really to be accurately at this speed. If less than this speed, it cannot adonan, the mixture content too will affect the quality. It means the dough is too soft, or maybe the dough is too hard. Maybe the food technologies will signal to you, will mention to you, you are design consultant. So the food technologies, not the engineer talking about the space. They cakap you only have to be fully automated lah. That the engineer will tell you, engineer from that company, but you are the design consultant. The food technologies there mentioned to you, but the dough quality need to be this speed. If too high, if too low the speed, it will affect the dough quality. So you got to be careful. Because you look on the internet, it's simply fully embed. Tapi itu just this product lah. Tetapi sometimes depend on your client. Kadang-kadang if too high the speed or too low, not it want they already done the calculation. So they did mention itulah, you have to look at what is the speed lah. Macam ni yang you cakap ni, your speed is berapa RPM tu? Speed of the
131 order if 5 liter.
131 RPM.
Yeah.
The bigger the size, the lower ke, the more the
The bigger
speed.
the size, the higher the RPM, brother.
Okay, it quite fast lah because I'm talking, I just assume about 60, so 151 RPM, so it means, okay, you have to make a research, is it have to be accurately? Kalau katakan macam, okay, you want to go for 5 liter, 5.5 liter, kalau you cakap 1 to 1, 131 to be exactly, kadang-kadang you can go to 1330 and you need to justify lah because remember, as I told you, kalau you want to remain accurate in term of constant velocity, I'm talking about constant velocity, we go for spur gears. That's why they say when you discuss with your group, kalau you want high efficiency and precise, we go for spur gears is more precise lah. Tetapi the bad thing about using gears, you cannot go for longer center distance, and also about the cost lah. You need a lot of stage, you need more stage of gears to maintain the center distance between your input shaft and your output shaft. That's why you go for, if you look yang this model, they use pulley and belt. You use pulley and belt. Tetapi be careful, so you make a justify why you use pulley and belt. Okay, I'm talking about, okay, macam the other section, they are doing the same like you. You are section A, like section, there's a group section, they are doing like you also, dough mixer. To make dough mixing, dough machine lah. It's a mixer, food, liquid and flour, and they making a dough. They are focusing on gears because they already justify to me because they create, bukan they create lah, they make kind of research and they expect for this dough mixer. So they're doing spaghetti. Use Yejian and the group you using fully embed. Okay, I have no comment, no again that. Tapi that one, the other group they use gears. Firstly, I want to ask them why you gears. So they justify to me because their dough mixer is maybe different than yours. Their dough making machine is because they need to be precise. That's why they use gears. Because you can use this pulley and belt, but they justify to me, the group, they explain to me because they make a research that their dough mixer, they need to produce this dough to be like they create a station is good. Something interesting. Even we are just talking. You mean like assume like they discuss with the client something like that. They create a station like this, and they also make a research. They don't simply talking. And this dough have to be really this precise speed, this exact speed. To be precise, high efficiency. I mean, your precise machine efficiency is higher. So that's why the reason they're using spur and gears. So okay, I agree. I prove that they're using gears. They have 2-3 shaft because long center distance. Input power from motor, then another middle shaft and the output shaft. So they're using spur gears. Like you Ijan using pulley and belt. Okay, I have no argument on that. So you justify lah. Kalau you punya expectation is around roughly, you justify in your report. Clear tak, Ijan?
Clear, Doktor nak tanya, cuma nak tanya je kalau drawing permulaan saya macam ni, sebab simple drawing dah aja lah, sebab cuma discuss aja kan hari tu. Doktor cakap nak sketching, so I cuma simple drawing dah aja. Tapi kalau
Ni Ayan, ni explain ni. You buat occupying space dulu, bounding box dulu, boleh. Make a bounding box of your machine. I need to see this.
oh, okay.
Tak,
So,
what you buat ni is okay, tapi is not a proper, not ikut, you are not following the exact procedure lah. Too fast to discuss on the what is the power, where is the location shaft. Too fast. No, hold on first.
so cuma drawkan itu macam dimension inside. We nak determine. So we need to put some scenario inside first, and then we follow by the discuss about DC motor per minute, shaft length, something like that lah.
Yeah, first you punya overall size of your machine, okay? Number one. Okay. Number two. Okay, speed dah define kan? Berapa tadi? 131.
131 just now.
Okay, 131 meter. Okay, you dah discuss with your group. Okay, you punya, what is the horsepower of your machine? That is the second step.
Sorry, what is the?
Power of your machine, your power of machine, berapa?
Is it normally electronic power, PC motor, something like that?
Tadi the image that you show me tadi, the table tadi just now.
A little bit confusing. What I mean that? Oh, power, input power.
Yeah, this one. Power, input power berapa?
300 is that?
300.
Watt.
300 watt, okay. 300 watt, okay, meshing speed is 131,
Yeah, here.
okay, 131. So have you decided what will be the motor you're going to use?
We think maybe electronic DC motor because there's a single way only, there's no reverse or whatever.
So 300 watt lah, 300 watt
300
motor.
watt. Maybe
Okay, your speed is 131, your speed is 131. Okay, okay, you punya second step, okay, you dah know your overall size. Your machine, actually you, okay, you already have the image, the sample product kan. So, okay, this is your already your occupying, okay, overall size. Okay, this machine, okay, this step we need to do lah. You need to identify the zone of your machine. I think lah, if I'm not mistaken, we have two zones. One zone is a power unit including your power transmission lah. Betul kan? The another zone is a mixing unit that output your machine. Betul tak, kelas?
yeah, total.
Okay, you decide lah. Sometimes power unit ni, you make a block. So you want to do it like this. Okay, this will be a block for your power unit. Betul tak? Kelas.
Okay, total.
I'm talking this is one way to do it. Better we go step by step is much better lah, rather than okay, you straight focus on what of shaft you want nanti dulu. Then only kita design the layout of our shaft. Okay, so this will be your power unit lah. Power transmission unit lah, where your location of your motor and your shaft or pulley or belt or spur gears, okay? Understand what I mean? Class, are you listening or not?
Yes, total.
So this one will be mixing unit mana? You nak bawah mixing unit ke top mixing unit mana? You punya mixer lah, where is it? This one way lah, the one way I do it, I will do it like this lah with my group if I do it. This will be mixer unit, mixing unit, mixer unit, mixing unit, mixer unit, mixer unit is this zone. Because we have a lot of machine. Okay, pasal okay, of course Yijian ni pasal okay, Yijian ni I know you because you look on existing product. Okay, that's it lah. So why need we discuss already there in the image, right? Now I'm talking you don't have any idea at all. You want to build your own custom design. So you discuss. Understand that, Cloud, I mean? Pasal Yijian, okay, you
we
look
need
on existing
to
product. That one shortcut lah, you know. Okay, of course it will be. Sometimes when you do okay, you want to make food mixer. Sometimes your design. So you need to discuss. Okay, of course lah. Okay, if we look on the image that you just share, it's like this lah. Mixer unit, of course, here lah. So power unit. Tapi you need to plan juga. You need to plan lah. Rather than you straight away to where is the shafts and no. Do not focus. You are focused on the inside first, no. We focus on the overall dulu. We overall machine dulu, the layout of our machine. Understand that? So this will be power unit lah. Kita punya transmission unit. Sorry. Dia ada tiga part, sorry guys. Satu transmission unit, sorry, my mistake. Transmission, this my way lah. This my opinion guys, my opinion. Satu lagi kita ada power lah. Power unit tu either you want to use motor or you want to use diesel engine or do you want to use engine lah. Engine we have diesel or petrol. Or do you want to use motor? That's how you do things lah. Or maybe do you want to use solar power? And who knows kan? Solar power kan? Okay, nowadays kita save energy. I don't depend on your machine. I'm talking. Power unit, where is the location of power? Power unit is a motor location. Transmission unit is your power unit. Where is the location of your transmission unit? Nombor 3, what your machine will do lah. Okay, we are mixer unit because we are mixing machine, right? You design the layout. Faham tak? You know what I'm talking about? The block location of your ni. Understand, class?
Yeah, total, it's clear.
Tapi tak apalah, Yijan, you look on the image, of course, everybody's talking, macam dulu I give my student concrete mixer, of course they know, motor tak, depend juga, sometimes your concrete mixer tu have to be special design, different kan, no, we not, okay, one of it you definitely look on the white standard there in the market, Tapi when you do in consultant, you buat your automation machine like this, you kena, sometimes kita bukan buying standard machine, because in the market, they sell their product macam Yijian, you show to me. this is what they already make it commercial. Tetapi sometimes the industries, their requirement of food mixer sometimes do not tally to what the standard product that this Berjaya, what is the name of this company? Berjaya, what is it? Okay.
Yeah, Berjaya.
Product, Berjaya product. Berjaya product, maybe they focus, they have their own customer. Through their history, they have their own customer. Maybe bakery company, a lot of bakery company, they, through their history, they first they make a consultation with them, then they set their own standard kind of machine lah. They have it. Tapi sometimes industry, your custom design, pasal that's the design consultant job. Okay, on automation. Yeah, this one, machine design and so on. Automation, that's what you call under automation. So this thing you discuss lah, what is the location of your motor, what is the location, so your power transmission, first power unit, okay, you want to use, okay, of course lah, Yejian, you have this thing, you use 300 horsepower lah, so where is the location of your motor, and where is your punya transmission unit, no, to transmit that power, how you design the layout there, the location, and also dia punya occupying zone dia kat mana, the zone, where is the zone, and also what is the location, you punya apa tu mixer, the unit lah, your machine will do.
First we need to arrange the dimension to the mixing and
Yeah.
the power supply
Yeah.
part lah.
I don't want you to draw this block. No, I'm explaining to you the punya step procedure. So then only, okay, after with the first we know the size, right? The size, length, rod. Macam Yejian tu lah cakap, okay, the other group lah, pasal you don't have any reference you want to design. So this is how the way we do it lah. Because sometimes when you go internet, there is a product already in the market. Tetapi their product, yeah, you cakap, why not we just follow, okay lah. Tapi sometimes your custom design. So you, location of your power unit, your transmission unit, and your mixer unit. So then you make a detailed sketch. You don't need to provide me this block. This is a procedure. Then you sketch it. You sketch lah dia punya, you have a container, right? Based on that, from there, after you identify the zone, from here lah, you sketch actually. I just make a shortcut lah. So this one will be the shaft. What I need to see, this thing aja sebenarnya guys, all the group. I just need to see ni, bukan ni pun. Not this thing, you don't need to show me. This is how the step, the step. This is the thing I need to say. Okay, you punya, you make a proper sketch. Can you not so beautiful sketch like as long as your sketch tu can be understand, can be understood. You punya ni lah. You have shaft. Okay, you punya ni more is you have pulley sini, right? Okay, you already to use, so you punya ni lah. So from there we know lah. From make sure that you follow the overall size that kita punya ni lah. And you punya, from here, because that's why from here you can sketch guys. You punya, because kita macam design like a frame of the machine, the frame of the machine. Okay, pasal kita nak, we want to make sure that when you design, you just focus on the machine component, the shaft, the pulley and belt, and the shaft of the blade. That's all. This is our machine. So your machine is just a schematic diagram. So what is actually your machine? You just design, you just sketching only the working mechanism only. So what support the shaft? The shaft is mounted on a bearing. Okay, we have two bearing. So what is the bearing mounted on? The bearing is mounted on what? Everything is not floating in the air, right? Understand that, class? Macam you show your sketch tadi kan, everything is just schematic diagram. I need to see that exact thing. Your shaft, okay, you have this thing, you have, okay, you have, for example, so you design, for example, like this. You decide where is your motor location. Okay, your motor location here. Okay, your motor we have shaft in class. Motor are the shaft, but the shaft of the motor is so short. You want to use berapa horsepower tadi? Kilowatt, 300 watt motor. You look from Alibaba 300 watt. Look at the size of the motor from Alibaba. Take the size. So basically they have a frame. So what is their shaft in a size? Okay. Sometimes motor 300 watt that you get from Alibaba, the motor is too short. Just to tell you, sometimes the motor too short. the motor shaft. Even you cannot mount your pulley there. So your motor have to be connected. That's why you need to sketch anything. Guys, are you watching me? All are you listening or not, class? Class?
Yes, okay.
Okay, this is a motor you get forever. You make a sketch, sketch in. First you sketch schematic, sketch like this to this sketch. Okay, what is the length of that motor? The motor actually you cannot. It's too short. If you want to mount your pulley, actually motor from shaft from the motor shaft. They don't have. It's too short. Sometimes you need to attach. So it means you need to attach. So this will be your shaft A, right? A short shaft. That will be short shaft A. Where you mount, this will be your pulley. This will be your pulley. So you have to make some, this a thing, this kind of sketching I need to see. So this motor. Motor attached to this shaft. How do we attach this one? The motor shaft will drive this shaft A. This will be your shaft A. And you must have bearings here to support the shaft A. Bearing is somewhere here. Not there. So how do we connect motor shaft to shaft A? Mean by what? What component we use to attach motor shaft to shaft A? So you design So do you have two bearings? This pulley. How do you connect this thing? So it is connected. Normally motor when if I zoom bigger, this part if I zoom bigger, okay, this is a motor shaft. Okay, this is a motor shaft. Motor shaft steps. Okay, dia ada chamfer ujung lah. Okay, I just make shortcut lah. This part of motor shaft. So you have a coupler, coupler. Normally they will do that, okay? Coupler. Then this will be jointed. Then it will drive the motor shaft. A lah, this is your shaft A. This center line of your shaft. A coupler. You know coupler, guys? Coupler. I'm drawing section view lah. Coupler ni dia ada holes, and bolt and nut. Actually 4 hole lah because I'm drawing section view. 4 hole lah. This is top and bottom, bolt and nut. So you don't need to draw. Actually, guys, you don't have to make engine drawing for this one. I just need some sketching like in your report. So this is a coupler. So the coupler will drive the motor rotated. It will drive the motor shaft. Okay. So you don't have to make engineering drawing, guys. For you, you don't have time. Just I need some sketching. Okay, you do some sketch. Okay. So just to explain to you, the location of your motor. So this will be your shaft is. Now this is isometric drawing. So this will be your shaft A. So you check out this one will be the bearing. And this one will be the pulley. This one also the bearing. And the pulley will drive you punya boleh tak you I need to see at least one sketching like this. Boleh ke kelas? Can you do that? Bukanlah cantik sangat.
Like this one ke, Doctor?
Yeah, don't have to be so beautiful. Don't have to be as long I can understand your sketching. Tapi jangan cincai lah, buat cantik sikit lah. So we need to design. Okay, this will be your shaft A. Shaft A, and this one will be your shaft B lah, shaft B. So your shaft B to how is your shaft B mounted on? Okay, shaft B is not too long. Okay, start from shaft B. So where is your bearing? Bearing, okay, you have bearing here. Sorry guys, my sketching is not a good example of sketching lah. I just lebih kurang lah as long dia. Okay, this will be your bearing. Then how do you design? There will be another. Okay, is your bearing will be another bearing will be really on the casing because okay, this your mixer. How you design your mixer punya casing? Your container, not casing. Container of your mixer. How you design it? Okay, the shape of your punya container. Macam Yijan, you can look on the internet lah, the one, the Berjaya, that model, you can look on the casing. So, okay, you need to study. Okay, what about, okay, we have shaft A, this is shaft A. Now we have shaft B, okay? Okay, nanti if you are 3 group of you, group student A will do analysis on shaft A from motor shaft A and pulley and back, and student B will do shaft B, pulley and back already done by student A. Student B will do analysis on shaft B, fatigue analysis, also bearing. We have 2 bearing. Let's say that we have 2 bearing here. 2 bearing. What's the length of that shaft B? And okay, another shaft will be shaft C. Shaft C, the one that connected the shaft C to special design. Shaft C to the one that have blade. Okay, for your Yijian, you punya door mixing machine, door maker ni. Okay, door maker ni, what type of blade they are using, so you need to focus. Okay, this will be your shaft C. Shaft C. Okay, shaft C is, okay, is really shaft B is one solid, one solid shaft. Yeah, no. Actually, shaft B is different. Shaft B will drive the shaft C. Because shaft B we use a standard shaft, if I'm not mistaken, so it will drive the shaft C. Because shaft C is a special shaft. Shaft C is where you welded. It's kind of like shaft. It's a mixer. So what type for door mixer? We have a lot of mixer. So I need to see this guy because, okay, this bearing, okay, before I go to that, shaft A, okay, this motor is still floating in the air. The motor is still floating in the air, so you need to design. So because first it's good, you have this zone, you know, you plan, you buat the zone where you want to mount your motor. Your motor will be mounted on the frame. So what is the frame of, how you design the frame? So this is a frame, you design the frame has also the leg to support all your machine, because everything is not floating. Must be on something. You have to be make sense lah, benda ni. Relative or to make. Okay, this bearing also have to make sense. This bearing, okay, bearing we have housing or bearing. The bearing is mounted on what? Shaft is supported by 2 bearing, but the bearing is mounted on what? On frame. So what is the frame? So for example, you have how you design? How you design? For example, you design dia punya frame lah, frame box section or what? Okay, design dia punya frame to where's the bearing mounted on. And this one become frame for your motor. So this is the thing I need to see lah, benda ni structure of your machine. Bukan you just give me sir, this shaft. This not machine. Itu just like your assignment lah. Remember your assignment, they give you a free body diagram. That's all. We need to see the overall machine. Understand ke lah, class? You understand what I'm talking about, class? Class, you understand? Yijan, you show me the image of that tu balik. Saya nak tengok frame ni.
Sekejap Ni kan tu.
No. Itulah, don't show like this. This is belum.
Ni ke?
I'm afraid of you show. Not like, yeah, this one. Boleh zoom in tak? Zoom out.
Ya.
Itu je gambar dia. I need to see the frame. Nampak tak? They have frame kan to platform. They have a platform where you mount your motor and the shaft is there macam you, okay. Like yours is like this kan. Pasal that one, this diagram, the image photo that you show is kind not clear, right? We cannot exactly. So you have to make a sketching on this, the location shaft. And you don't need casing lah guys. Macam this for commercial purpose casing, but you need for your case is just what's up to look aesthetic, look nice. You have a casing to apa? We as long you have the structure to support. Okay, where's the motor mounted on? You have a platform, and you punya, okay, this is the container of your ni. But let me show you lah. Hold on sekejap internet banyak gerak. Can you apa tu boleh nampak saya punya browser
Maybe I need to
Okay.
stop the sharing first.
Okay. Alright. Do it. Boleh nampak browser saya?
Boleh betul.
Kita industrial. Kalau you search food mixing machine, dia go for domestic punya produk macam home bakery, yang flour punya mixer itu yang for kitchen punya produk, right? Industrial, we go for industrial food machine. Yeah, example to see the frame though, I want to show you. We have a lot. Macam ni lah. If you look on this Alibaba ada ni, boleh nampak kan? Kecil yang gambar ni. Mana ni gambar dia tak boleh besar If you look ni apa gambar dia tak boleh besar ni besar. Boleh nampak kan? Itu frame lah kelas. Are you there kelas? Frame. Where you mount your motor, your electric motor, the location. Tu ada frame lah. If you look on my live video balik. You design lah the frame tu macam mana to support your container. Because you mesti ada supporting structure. How you design dia punya tu. Boleh tak? I need to see this thing ni. Then kelas, kau dengar ke apa? Kelas, are you there?
Dengar. Tonton nak tanya jap pada shaft C tu nak macam mana cari shaft C punya kita kan cakap dia ada special shaft for mixing.
Itulah you how many person in your group? 4 of you
Three normally tu. Three.
Okay, 3 of you have to make an effort This is your project, not mine, sorry lah kan. You make a research lah itu dia. Kalau door tu, what type of mixer. Door tu shaft C tu. Kalau you punya, okay, ni shaft C shaft C ni. Okay, shaft C of course lah. We have shaft lah because shaft B have to drive shaft C. Okay, shaft C ni, boleh nampak saya sketch ni. Shaft C ni, the most simpler mixer is just we have a stick here lah. A tiny shaft stick here. This is the most simpler mixer lah. Agree tak guys? Kelas?
Yes, tak.
This is the most simpler mixing unit lah. Mixing shaft lah. So you have basic, your punya tertulang lah. Your bone is your shaft and you have a stick, kind like a cylinder, what we call it. Dia semua. Maybe you have vertical form pun ada. Macam ni lah, depend how you design. This is the most simple mixer. Tetapi be careful guys. For your mixing, be careful. They have a lot of mixer. That's why you have to make an effort for dough. What type of I'm not doing this project. So I need to see you to be independent. I want to see you punya effort. You justify in your report nanti. Why you use this mixer. For dough mixer tu macam mana? You dah buat research dah. Ijan, dough mixer macam mana? Okay, you have shaft, apa dia punya blade ni? I'm talking about blade. Sometimes we have a stick. The most simplest, okay.
Dia blade macam angle dia. Kita yang dapat cari dalam Google lah. Shape tapi tak.
Like this angle.
Ada dimension punya lah. Tadi ada macam atas, lepas tu jap saya cari jap tengok ada ke tak. Sebab tadi tengok tapi tak pas.
Is it like this angle?
Dia macam macam yang total drawing tu lah. Hampir lah, similar.
One angle like this, one angle like this. Okay.
Dia macam ada circle punya shape.
Dalam ni hollow, dia hollow lah, dia bukan solid.
Ya, dalam ni hollow.
So you make a research, if it is your blade, you make a research. Actually, we don't design, okay, why the blade, you have to be really detailed, why the blade must be like this to make, no. You just research in the internet for dough mixer, to make a dough machine, what type of blade they are using. Then you select that one.
So we just
yang stick like this. The one that stick like this, I believe yang ini for liquid. Ni. This kind of mixer, this is for liquid. Granular, yes, coffee bean, mixing, bean, any beans lah. You want to mix a bean, among bean to do something, or maybe coffee. No, be careful guys. When you do coffee beans, I'm not sure you are grinding machine or what. Pasal coffee bean, the output to be powder. No, we are focused not grinding guys. Kita not grinding machine guys. But tadi saya mention about coffee bean. Coffee bean normally they grind it and powder. You not grinding rather. That is different case of machine. They grind it. They have a cruncher. No, kita just mixing. Focus on thing. Maybe beans you need to mix. Maybe semi-liquid mix, food mixing. Maybe mix of powder. Kalau just a powder, this is thing lah. Simple saja, this thing. Tapi kalau you dough, yours is dough. Dough cannot be like this. Ada reason, I don't know lah. You make a research on that. It cannot be just a stick like this. Yang the one you say the blade ni ada reason because they need to dough the way kalau doing by hand the dough they doing by hand manual kan, the way tangan dia apa menguli kan, how they compress the dough by using by hand. That's why they replace because the engineers already done that. They already there standard there. We are not designing. Don't waste your time designing the blade because as engineer you can start. We focus on design the machine only. This is standard. We purchase this thing. Engineer, when you are doing design consultant, bukan all you design kan? Even the bearing pun you not design. Kita beli bearing, we order bearing. Even the gears we are not design, we order gear. Tetapi we learn the procedure of selecting gears. We learn the procedure of selecting bearings to make sure it's safe. When run is safe kan? Even the shaft, shaft we lace the step, the shaft, even the procedure of doing that. Even this macam this shaft, this blade, other that is not there in the market. Make an effort. What type of blade they are using? Okay, you say lah blade tadi like this lah. This one for dough. Dough mixer is lain. Kalau benda lain dia punya mixer. So you study, so you make an effort, do research. What is you punya tu? Okay, my point sekarang ni. Okay, let's say you punya ni is like this, hijian, you punya shaft. Okay, my point. Okay, you make a sketch. So you have something like this lah. You punya ni. Okay, be exact lah. You dah give overall dimension tu you know. You dah tahu overall machine size and then you boleh allocation from here. You boleh set the detail dimension. Where is the size, the length of your shaft and the location. You understand that class? The location. Okay, then after you have this dimension, then only you can plan. You can plan. Okay, from this, you make a sketch from the side view. This is our location of the pulley. And this is our small pulley. You make some schematic diagram lah. I'm not sure lah. So, okay, this is kind of like, this is by hand. You don't have to draw solid work. Okay, the other section, one of the group, they say want to do in solid work. I said, okay, if you can do solid work, it's not compulsory, you can do. Because the advantage, kalau if you have, okay, first you put overall machine, then you can plan it by doing, okay, it's good also. But it's not compulsory, it may be too much for you lah. You make model, okay, maybe, okay. Shaft diameter later on. Shaft, remember, shaft diameter, because you have shaft A, shaft B, shaft C. Hold on first. The one you decide dulu the length of the shaft. Understand that class? Length of the shaft and where is the location? The length of the shaft B, what is the location? And this the length of shaft C lah, because the size of your container. You give detail lah, plan, detail can dimension the size of the, because if you know the size of your container, then you know the size of the length of your shaft. Okay, the width of your container, then you know to position where is your pulley. So locate all the coordinate of your component, your pulley, small pulley, big, your shaft A, shaft B, where is located, the bearing, where is the bearing mounted on. So what is the distance of the bearing? Bila you dah all detailed dimension, I'm talking it just you can do it by hand. Not necessarily you have to make engineering drawing. Engineering is a final output. Engineering drawing that you have learned in year 1. Remember, you have assembly drawing, you have explorer drawing, and detail drawing, all common. That one is meant for to fabricate. Engine drawing is the last thing after you dah design. You have do in component design. You have do calculation, the size of the shaft, you make fatigue analysis, and the shaft's diameter is safe. Bearing also select. You know the size of the shaft, location of the shaft, material of shaft. That's all. Everything you dah calculate. Engineering calculation is right. Macam what you are doing your project now. Later on, then only. Even the material already select, the material of a container, then only you produce engineering drawing. Okay, that is beyond your scope. And for this project, you know, you don't have to produce engineering, just a sketching only. Then you do calculation, analysis. But yeah.
So tanya jap, so kalau dalam shaft C tu, kita cuma search dalam Google, so kita can see what the
Yeah.
commercial product use.
Yeah.
Maybe he use a
Yeah.
shape like this at an angle,
Yes.
and then
Yes.
we just justify. We said that because of the commercial product use this for this type of the machine, so we just follow it, something like that. We no need to calculate or find the specific specification
No
for
need.
the shaft C lah.
You're right. No need. This is standard. That is there in the market. all component machine, bukan semua you design. If you design your own, your machine will be very, very expensive. If you have standard component will be accommodate to your machine, it will become cheaper because there is a supplier there. There is a player in the industries, other vendors, other supplier. That's why they have is these industries. A lot of things you will discover, a lot of things, industrial supplier. There will be for mixer. Ada dah, you just search saja dah. That's why you are year 3 kan, quite ni lah. So you have 3 of you. Try to make an effort, search what type of blade they are using. Okay?
Okay. Sebab takut saya nanti total nak check up dia punya angle ke pasal
No.
saya pun confused lagi, tak pernah belajar benda ni, macam mana sih hari ni?
Tak. Benda ni ada standard. Use standard mixer blade. Katakan you don't have that. Katakan let's say you don't have that exact the mixer blade for door is not shaft. Maybe they are doing a rod, vertical rod. They have so you have to make a judgment. So you use the same type of blade. So you attach. So this is my design. This is what you look from. You share to me. My design is everything is horizontal. That I said is shaft C. This is my opinion. I'm not sure. The one that macam the one yang ini. I don't know what machine is this. I just simply from ni. I don't know what machine is this. Double ribbon powder carbon steel dan apa ni? Auger apa? Auger blender apa? What is auger?
Sorry, Tata?
Auger blender. What is auger? English. Auger is what?
Saya pun tak sure.
Is it food Pasal I type food industry. Kind of food auger blender. Mixer. So this yang the one this is auger blender lah. Auger blender, I don't know. Is it powder mode or what? Okay lah. We don't know inside. Yang dalam image what you see. We cannot ni kan. We cannot see what's inside there. So I believe it will be the shaft. Shaft from, if you look in this image, this one they already use motor. Macam this kind of machine is so simple. Direct from motor, it mean they purchase standard motor ni. They purchase the standard motor. Macam like this machine, they purchase exactly what is the speed of the machine, then they buy this motor. They mean this motor, they try to seek for the exact RPM. Tetapi this one, when you want to, this motor is kind like special. Now, if you look, this motor is vertical here. Nampak tak? It's vertical. Then kemudian the shaft here is horizontal. So this motor, inside this motor is so expensive. I believe that this motor, the green color ni, this machine, I think is very expensive. Because why? The motor is special kind of motor. Nampak, this is not typical motor. Okay, the motor is vertical and the one, the shaft is horizontal. It means inside the green one is a whole motor set supplied by the motor industry lah, motor punya manufacturer. Vertical motor is vertical but the shaft inside there is this special kind of motor. It means inside there they have bevel gears, bevel gears. So it will drive vertical and vertical. So this motor is so expensive. So then only they have the output. They have kind of like a gearbox lah, including bevel gears. So they have the output speed. So but for the disadvantage, I believe that this one will be so expensive. So the machine is so expensive. Because your case, that's why you don't need special motor. You just take similar motor and you design either spur gears or to get the you punya requirement output speed that you want. Okay, we don't know here the shaft here. The shaft here they have mixer. What type of their blade? I try to make an effort. Okay, to answer your question. Okay, you finish this sketch. You sketch, you lay out, your location, you put all the location of motor on the white frame, no such thing, everything there. Need to remind you, motor must have the platform. Need to see your overall sketch. Motor to what is the platform, so then you will know, you can decide what is the length of your shaft A, the length of your shaft B, the location. That's why I told you, maybe you have side view, okay, you punya location. You know some dimension from here to here. You understand what I mean? Dimension from here, the location your dimension, the total height from ground berapa you punya ni. So that you remember you punya pulley embed, you have initial center distance, pulley embed, then kemudian you adjust your new center distance after you set the standard length from Mitsubishi, adjusted. So you sketch balik lah you punya the height of your ni lah. And the location, I hope you understand what I'm talking about. You decide, okay, the diameter of the plate. That's your punya analysis nanti later on. How do you attach your motor lah? Motor is at the back here lah. Motor is at the back. Macam mana dia punya location lah? Jadi the exactly coordinate of you punya ni. And also the bearing is not floating. You design the frame and so on. Okay. Okay, then you plan you punya, then that's why this will your power unit, this will be your transmission unit, this will be your missing unit, your missing unit. So okay. Okay, talking about shaft C, shaft C will be connected to shaft B. Shaft C will be connected, okay, if you will be connected to shaft B, it means that this is your shaft C, will be connected to shaft B by means of, I mentioned to you just now, coupler lah. You know coupler kan guys, kan? You must know what is coupler, right? Plus,
Yes, sir.
coupler tahu coupler. Coupler ni dia ada bolt and nut lah. Dia ada 4 holes, bolt and nut. The simplest, the common way lah to join these two shaft is coupler. Okay, coupler. I made a session view of it. Okay, understand? Coupler. Coupler. So you would, okay, this will be your shaft B. This will be your shaft B. Shaft B here. Okay, and shaft B ni, they make you not just these sketches lah. You have some sketches. Not for me guys. It's for you. Nanti if you want to do analysis right after this, you have done the sketches. You have done the dimension, the length of the shaft, not the diameter. Diameter is based on your fatigue analysis, on your bearing analysis. And then will decide what is the diameter of your shaft. You make a step and so on. But the length tu you need to define earlier lah. This how sometimes if you don't know. Kalau you show me Ijan, macam you show me, sir, we want to do this bearing like this. This one will drive. You said tadi you buat drill legend kan, you buat macam ni. Okay, if you want ni, you cakap this your machine, that's not good lah. I'm not so clear apa machine you want ni kan. And also when you want to do analysis, you don't know which is which. What is the size of that? Where is the location? What is your center? Distance, the coordinate, what is location, this shaft mounted on what, the bearing location. That's so better to plan. Understand class? Plan like this, make a sketch so you know where is the you punya coordinate of your component. Clear class?
Yeah, clear, Doctor.
Doctor.
So for the thing that without the rebuild and then the power, the thing that we haven't learned yet, we just
Yeah.
use the common one lah, or
Nanti
we
dulu.
found.
Jangan analysis dulu. Ya, itu saya cakap. Plan dulu. Okay, bila you dah run, okay, ni I'm talking to this one shaft C, shaft C. Shaft B, you know shaft B here. Shaft B, of course, you have pulley. You have pulley here lah. And you have bearing. I told you bearing ni, you need shaft ni, you need to know the location of your bearing. This one you need to set the location of your bearing, the length of your shaft B. This is your shaft B. So you have some, maybe where you want, because you cannot mount your bearing at the end of shaft B. Pasal shaft B ni here they connected to shaft C because you have some space for coupler. Coupler you don't need to sketch, you don't have to analyze, do engineer. Coupler is as mean as long as they have the same top, it will drive C. So but as you guys, it will be connected by coupler, coupler. And where is the location? I'm talking about the shaft B. This shaft B. Where is you design? Where is location you want to mount? Okay, your bearing will be somewhere here. It's not at the end, right? Okay, somewhere here, quite in close to the end. Okay, this is the location of your pulley. Okay, you must know the dimension. Then only you dah detail. Then only student B can do analysis on shaft B. Pulley, shaft A. Student A already done pulley and bed, and also bearing and shaft A. And pulley already done. But student B have to focus on shaft B analysis. Where is the location? Remember you punya shaft fatigue analysis. Okay, this one will drive. This on the same top, it will drive your shaft. Okay, this is shaft C. Shaft C, how you design? You cakap, okay, you look in internet, the blade is like this. Okay, something like this. The blade is like this. Okay, and something like this. Okay. Okay, you don't need, okay, this is something standard. So, okay, this is shaft C. Okay, shaft C also not floating, guys. If you look on the sketch, your shaft C is not floating. Your shaft C is, apa tu, dia shaft C is located, is mounted at the hinge of this casing or this container, right? This container. So shaft C ni coupler is inside. So it means you have the bearing is somewhere inside to support the shaft C. Because this one connected to coupler. So yang ini the shaft C also they have bearing somewhere here lah. This is my opinion. You have bearing. So where is the location of your bearing? And also at the hand here, at the wall again, or the wall of this container, they have a hole. That is the location of bearing. So your bearing is at the end. Design. Okay, shaft C ni, nanti you make a schematic three-body diagram of the shaft C. Shaft C. So this will be your bearing. Okay, this one will be your blade. Okay, will be your blade, and this one another bearing here. At the end here, and it's connected together. Okay, this is shaft C. So student shaft C can focus doing analysis on this. You dah define so all the location ni, all this dimension ni. And also you punya dimension of the blade also you kena tahu jugalah. What is the length here, height ni, okay? What is the from the curve to there. Okay, yours is like your blade lah. Okay, different group maybe different kind of blade for mixing. Maybe the simplest one is just a stick like that. Okay, another question I need to find out. Okay, after you have done this, okay, you give me your sketches. Okay, I satisfied with your sketching. Okay, I approve it. Then you can proceed to your engineering analysis lah. You already have this kind like sketching. Okay, if you want to do analysis, guys, are you listening? Boleh sikit? Kita sampai pukul berapa? Boleh just continue, guys.
Boleh. Ada masa banyak lagi tak boleh.
Kita don't have class on the Thursday, tak ada. So I need you to focus on this, okay? Okay, macam mana kita nak start analysis after you are done this, you know the dimension. Where do you start our analysis? My question. Macam mana? Where do you start? Pasal your report ni, the main content of ni is engineering analysis. That what you have learned during your study here, this course kan. Kita dah learn about fatigue analysis, shaft, kita dah learn about spurges, kita dah learn about pulley and belt, kita dah learn about bearing, itu je lah kan. Macam mana kita start? How do you start our analysis? Bila you dah know the location, the length of your shaft, semua shaft length you dah define kan? Before analysis, the length of the shaft, the location of your bearing, location of your bearing, location of your pulley, location of your spurges dah define. Faham tak kelas? For shaft A, understand tak?
If we want to define the diameter of the shaft, we need to find some justification or resource or what?
Okay, as I told you, diameter of the shaft, hold on. Itu later on. Diameter of shaft will be affected by your bearing selection. Okay, you want to start your calculation. You have done this, macam I want expect you. This week I want you to focus on this. Okay, for analysis, hold on. Tapi I just give you guide for analysis. For analysis, okay, after you have done that, analysis begin at what? At motor lah. From shaft A. Macam for example, you are using pulley and belt. Okay. Motor you are using 330 watt, right? 330 watt, and the motor RPM is berapa? Berapa RPM motor?
Sorry,
Ijan,
your
case.
motor.
Motor RPM.
131 tak ada. Just now we
131.
my crew found that one lah.
Okay, you start your analysis here. So you have motor. You make a circuit diagram like this. So this one will be your shaft A, right? And this will be your pulley. And you have bigger pulley here. Remember in your assignment, okay. My question is, do we do shaft analysis first? Okay, this is shaft A. You start at shaft A. Okay. As I told you here, is we man jointed the shaft of motor man by coupler. So we don't need to draw you don't need to analysis on coupler. You mean the torque from motor transfer to your shaft A. So you know the power of your motor. Age of the motor is 330 watt, right? 330 watt. Kalau you use motor, tak ada horsepower, tak ada. Pasal pulley and belt, we are using gears, right? Pulley and belt, we are using English unit kan? Horsepower namanya, HT horsepower. Boleh transfer to horsepower lah this one, Ijan?
Ya, kan guna formula saja.
Yeah, convert to horsepower. Can you get the horsepower motor yang for this? Get directly your motor yang in term of horsepower. Okay, the speed is 1. Berapa tadi? 13. Motor speed is 1.
131 tak ada. But it's very small one lah. Maybe our group will found
Yeah.
another.
The output speed, your machine speed is?
262 double kan?
Oh,
262 doktor.
biasanya kita reduce speed. Small pulley, bigger pulley, you reduce the speed.
Oh, divide by 2, divide by 2.
Check balik the table tadi.
Think that is 131 for missing speed. So for the power, then I think it should be 262. Is it correct like that? Like that?
You have to be exact, yang you use 5.5 liter kan? 5.5 liter kan?
Yeah, 5 liter doktor.
5 liter, what is the motor? Power input dia berapa?
Power input is 300 watt doktor.
300 watt you convert to horsepower, then what is the speed of the motor?
300 watt convert to the horsepower is 0.4 horsepower doktor.
Okay, apa tu? No, the speed of the motor. The shaft speed.
Speed of the motor, if time 2, I think is 262 doktor. 262 run per minute.
Tak, it's already stated in the motor spec dalam mesin tu. Ada 262
Tak ada. Kalau doktor check up dalam motor speed tu tak ada. Kalau sebab saya based on 131 time 2 lah.
Mhm.
So kalau doktor nak cuma based on motor tu tak ada. Saya belum cari lagi lah. Tak dapat cari.
Be careful about that. If the ratio of the bigger diameter pulley and small pulley diameter is 2, of course this 262. But be careful. Are you sure the diameter ni is 2 times bigger here? It's exactly 2 times bigger. Yes, this is 262. Be careful about that. So normally you get the motor and the RPM. From there you can design you punya minimum pulley diameter. Okay, what start first in your okay, student A will do analysis on, you not do analysis on shaft first. Okay, if you're using gear pulley and belt, okay, sorry, you're using pulley and belt. Okay, but now you have bearing. Which one first? Bearing first or shaft first? Which one first? I'm talking about shaft A analysis. Student A. Yeah, you are right. Bearing first. I would suggest bearing first. Because shaft A, okay, you know, because, okay, this is your shaft A, right? You know your reaction, you know the reaction of your bearing. Okay, you have O bearing here and you have at A, you have pulley, right? Hold on. No, sorry. Sorry, you are wrong. Pulley and belt first. Sorry, my mistake, guys. Pulley and belt first, not bearing first. Pulley and belt first. Clear, class? Kalau you tak buat pulley and belt, you cannot get the reaction at the bearing, kan? This O, A is at your pulley. O, A, B. B is also bearing. O, bearing. A is pulley. A is pulley. You must do pulley and belt first. Pasal pulley and belt, first is pulley and belt. Sorry, guys, my mistake. First is pulley and belt. Macam like proceeding in your Mitsubishi. Okay? Selection of pulley. From pasal pulley and belt, they don't depend on the shaft. You don't need to buat shaft free body diagram. So you need, what is the, you punya, to get that in your spot, because we learn in English, right? HT is berapa, 0.4 horsepower. Get the H design plus times the factor kan. H design is apa tu, KS times HT. KS ada apa tadi, I pun dah lupa. KI, KO. Apa, idler, environment and apa benda, correction, KO kan. The one, so you get your design. So through the procedure, you get the standard length, get the what is the speed. From the speed, just you need to speed of your motor. Then you will know what type of bed section, bed section A, B, C, or D. From there you get what is the minimum. That's you decide what is the minimum pulley diameter. Minimum pulley diameter, then only get the number of belt, get the number, and then you get how many number of belt. Okay, maybe 1, maybe 2, okay, number of belt. So you know that from here, diameter pulley. Okay, from here, then only you can do force reaction on the shaft. Force reaction on the shaft, can you? Okay, you have this one, you have apa? You have torque here. Okay, this one you have T1, T2 lah. It depends on how kalau rotation at this. Okay, this will be your T1, this your T2. But your T1, T2 ni guys, biasa we have angle, we have angle. So you mean your X, because let's say you punya this X axis, Y axis, Z axis. So you buat X ni, you punya reaction at bearing. Okay, this BY, Direction salah tak apa, as long as corner BY apa BYN BZ BY BZ or Y or Z ni for Z Y BZ ni BY, so we can get the reaction of your bearing. Mula-mula first is fully impaired, then only you know the reaction of your bearing based on the free body diagram. Okay, you get your free body diagram. You be careful, I'm talking about this top one, top ni, you ada tu lah. You ada angle theta. Remember, you can get your theta. Beta, beta is I told you. Theta is angle of rep here. This is your theta. You can get your angle beta. Nanti kalau tak apa, this one later on, you tak understand, you boleh consult dengan saya. I can help you on this. Okay, then you back, and student B will do shaft analysis on B. Okay, shaft. Okay, student B, shaft B at the top. Shaft B at the top. Okay, shaft B at the top. You have belt here. Okay, belt is like this. Okay, you know T1 and 2 is the same. Okay, this student B will do analysis. So you have reaction at this bearing. This also O, A, B. This is shaft B at the top. Student B, because belt is already done, the diameter already done, the biggest diameter size already done by student A. So student B will only focus on, okay, this one I forgot. Bearing, first is B belt, then is bearing. Bearings, you know bearing selection, you get all the reaction or O. Get the bearing at O, B. Okay, this one you don't have thrust load. So you go for radial ball bearing sajalah. Table 14.2 get the west delta reaction at O. Table 40.2 you go for extra light, light and medium. Okay, okay. Bearing okay, I go back yang student A for bearing mula belt, then after belt you go for bearing. Bearing you reaction at O. You select bearing at O, okay, bearing at O, then you go for, okay, then only will define the diameter of the shaft because of the bearing. Okay, second is bearing. When the bearing, you go, bila find the reaction of O, remember you calculate your CREQ, required capacity, then you go radial ball bearing because we don't have any thrust load here. Then, apa tu, table 40.2, you select what is the bearing ball size from extra light. You look on the maximum, nearest maximum standard capacity from the table. So you got dia punya nearest, dia punya capacity apa CREQ dia, C required, the nearest maximum, then you go for table 40.1 to get for extra light, light and medium lah. Okay, extra light, light and medium. So because extra light will become bigger ball, light will be smaller ball and medium little bit smaller. But kalau smaller tapi little bit wider lah, dia explore around itu pasal the ball bearing is bigger. Okay, for medium series. Okay, so you decide. From there you decide. For maybe you go for light, not extra light, because extra light is too big. The ball is too big. You go for 40 centimeter. It means too big. Maybe light series you go for 30 or maybe 20. Then you go for 20. Then only you design your shaft. Understand that, Clive? I'm talking about. Class, do you understand? Are you with me or not?
Yes, brother.
From there, okay. From there, you design your shaft A. I'm talking about student A. You design, okay, at the end we have bearing at the end. So, okay, you said the bearing 2 is 20, you go for 22. Light series 22 is the ball. So, bearing is at the end. So, this one will be 22. Diameter here is 22. Bearing is like this, 22. Then bearing ni we have step little bit, step. Okay, this one will, sorry, let's say the bearing is 20 for light series. So, this one will become 22 lah. This small diameter, because bearing dia mesti ada. Can you see my sketching? Bearing is bearing ball tu at the end, because at the end of the shaft is 20 is for the ball of the bearing. Using light series, for example, you're not talking about it. So you judge lah ball bearing. Okay, so this one shaft. Okay, shaft this is 20. Yang ni make it bigger lah. Smaller diameter shaft is 22 because they need step. This 21, maybe they need extra 1 meter or maybe 24 millimeter for the extra 2. Pasal dia need step, so the bearing tu will not slide to the right. Okay. And then kemudian you ada pulley. Pulley dia ada bigger step. Nampak tak kelas my sketching? Kelas? Hello kelas? Kelas, korang ni dengar ke tak dengar ni?
Yes, doctor.
So bearing, you design your bearing. Bearing, okay, this is bearing O. Bearing O, what about bearing B? Bearing B, be careful. Bearing B, maybe the reaction, I believe it is symmetrical. Kalau symmetrical, you punya case like this, is sama je. Because symmetrical the length, it depends. Kalau symmetrical sama, ataupun you calculate juga B. What is reaction net B? Procedure CREQ, take table 14.2, the nearest maximum, go for extra light medium. From there, you can know the bore, sub-bore diameter. Then you go for table 14.1 to get the bearing code size lah. So you decide using, for B also using light series. So be careful lah. I just assume that it's symmetrical lah. Kalau symmetrical sama lah. Kalau not symmetrical, maybe the bore tu, maybe this one is different. Maybe depend kalau if to me is this is sama lah kalau the same distance kan. If the same distance, if distance here is the same. Kalau the distance is not the same, because be careful lah. Kalau the same distance, it mean your O and B is the same bearing. You use the same bearing. If not, it depends on the layout. Because okay. So you put the bearing here ni. So then you design ini lah, the diameter of the shaft is 24. Then you make this one you design bit step, because the bore of the pulley of the bed itu they can custom design. The pulley bore they can actually you consult with the Mitsubishi what is the bore size, tapi tak apa, we don't know what is the bore size of the pulley, we can design on D is 24, you can design D is a little bit bigger to mount your pulley location. D is let's say 34 about, kita ada shoulder kelas ini 40 6, let's say 5 maybe 4 30 apa 34 plus 32 lah katakan. D is 32, you design lah 32. Faham kan? Okay. Pulley and bed you already done. I'm talking about student A. Pulley and bed already done. Pulley and bed already done. Then only the last, okay, so student A. The third one is shaft analysis. You already know the location ni. Correct kan? You know the location your pulley. You already done. Okay, ni, you design this one. That the location, the length of your step, the length here from your loading of your bearing here. What is the loading point? Remember you bought shaft analysis at this shoulder. Which one? This shoulder. KF, KT kan? Remember class? Class, are you with me? Faham kan? Be careful lah. Kalau yang ni, I believe you have, kalau macam ni, you punya pulley and belt ni, be careful, you ada angle. You ada angle. I mean, you have SY and exact plane you have to consider lah. SY plane, exact plane. Direction. So, remember for shaft analysis, so you do XY plane, free body diagram, shear diagram, moment diagram. Then you do shaft fatigue analysis, moment diagram, XY plane, shear diagram, moment diagram, exact plane. Be careful The pulley ni ada beta, kita XY plane, kita ada cos sin beta. Be careful. You must know about that. Pasal dia ada angle. T1 and T2 is not the same balloon. Nanti you exact plane ada ni sin theta, cos theta mesti ada. Pasal ada angle is not straight. Because before this you punya pulley and belt is just straight. Parallel, actually no parallel. Because this ada angle. Angle beta tu ada. You can calculate based on your angle of rack. Then you do ni. Okay, tak apalah. Just explain to you guys. But for this week, no. This one later on. You hold on. Because you cannot do this if you don't have this thing. Kalau I'm talking again. You cannot prepare this thing. You cannot prepare this thing dulu. That's why I want you to focus on doing ni lah. Dimensioning tu semua saya cakap tadi. Faham tak? Kelas.
So total for this week, we focus on drawing the schematic diagram like this, the overall dimension,
overall dimension
and then
first.
we draw the all design position, something like power, work positions, and then the mixing machine is which position, what do we want to design, and then what is the missing shaft. And then for next week, we go to engineering calculation, something like that lah.
Yeah.
Okay.
Tapi next week kita belajar bolt and welding pula, itu cerita lain. Yalah, tapi you punya ni lah. You don't depend on the content of syllabus.
Tutor nak tanya sekejap. This major project we need to pass up in until the due date is until when lah?
Saya at the end of study week. Ada study week ke? This semester do you have study week?
I think it's 6 or 7, right? Study week until.
Tak lah, normally ini tak ada. Saya masa during your early of your final exam. Early period of your final exam.
Yeah,
or
because
maybe
in this semester we got intern, so actually our final exam will be early a little bit lah, Doctor. But it's okay. It's
okay,
still
during your final exam. Boleh?
Boleh. Sebab Sebenarnya yang test 2 bagi subjek ni adalah 30. So
Ya.
I think it's okay lah, Doktor.
Tak, report ni, main content of your report is just your analysis. Tapi you have some few chapter. Nanti I give you the format a little bit lah. You kena follow that format. Dia tak ada you have a written long apa. Have a lot of writing or in chapter. No. Just a few chapter introduction a little bit. Like I mentioned to you, why you need some other chapter explaining. You come up this machine why you use Spurgeon instead of VBAP. Macam your Yejian, you use why you use VBAP instead of Spurgeon. You ada justification in the content. You have to
Yeah,
justify
because
the
actually
explanation on that. Yeah.
we found Google on a lot of specification commercial product they use range
Who's-
of the
yeah.
RPM. So we just use Rebel lah because we believe that if there is no precision, they all use the range. So we believe that we use Rebel is more economical lah.
Ayolah, tulis lah itu dalam chapter. Nanti dah ada format chapter introduction. You justification, you justify why you make a decision to do. Who's your client? Kalau boleh make it interesting. Boleh? Create.
Boleh. Doktor.
Who's your
So we
client?
just
What's...
confirm again. So for this week, we just do the overall dimension lah. We no need to use to draw or found the shaft dimension, something like that, right, Doktor?
Tak, ikut buat ni. Zone dia macam mana. Lepas tu detail sketching. This is one sketch. This is one thing. I'm talking. Bukan 3 sketching. This is the thing. First,
One sketch, Doktor.
this one sketch. The steps like this. Do it like this. First is what is occupying space. Ni. Then zone it. Power. I'm talking not for you, Eugene. Pasal Eugene, you dah ada itu, you follow itu sajalah if I'm not mistaken, right? Katakan you want to make your own design. I'm talking for the other group. Then you design what is the zone of your power unit. Motor can be a lot. Sometimes you use engine, can use motor. You decide lah. How many horsepower motor. The size of your motor. Look from Alibaba. So then you can the zone of your motor. Look on the image of the motor. What if motor kind like dia punya shaft dia macam mana? Power unit location, transmission unit location, and your machine location, mixer unit. Then you detail the same sketching lah. You detail kan? Detail lah. Saya punya sketching ni pun tak cantik. You sketch kan detail. You put some more detail than for you to get know the location of all your component. You detail it. The blade, how the blade you're going to use. Macam pulley and belt. Detail. Little bit detail lah. You don't have to be so beautiful lah. Your sketching as long you and your group. Actually not for me guys. You and your group can discuss tu je. Clear. Understand Kalau you punya sketching is so terrible, your group member also cannot understand. Susah lah.
Okay, Doktor. So for this week, we do until this one, right, Doktor?
Yeah, I need to see this. So
Okay,
you post me in the WhatsApp in this week. So we don't have class on the Thursday. So I need you to focus on this. By the end of this week, at least you show me you have some dimensioning lah. I want to see.
So Doktor, we need to inbox Doktor, or we just simply share on the WhatsApp group?
Tak, you post personally WhatsApp lah. Kalau
Okay,
you nak post, kalau you nak put in the WhatsApp group pun boleh. The group can share kan. Kita share the knowledge lah. Maybe helping each other lah. Maybe it's okay juga you post in the ni. Helping the other. So mungkin sometimes the other group stuck and they don't know. But it's okay to me. You can post in the WhatsApp group if you want to. Or you can post personally WhatsApp ni.
Okay, understand. Thank you, Doktor.
Okay, welcome. Okay, I think tak ada apa. Ada apa vision nak bangkit? I think that's all lah. For your project yang for this week.
Doctor,
Yeah.
actually our group have prepared a sketching. Do you mind me to share our sketching to you?
Boleh?
So this is our sketching. Can Doctor see it? We choose the ribbon blender. Our product, the food we mix is instant breakfast cereal. This is our rough sketching. We haven't sketched the frame that Doctor mentioned just now.
Okay, you bukan industri punya lah. You go for domestic lah.
Yeah.
Oh, ni lah. Boleh lah, boleh juga. You domestic food mixer. So you dah expect the okay. Itulah as you show me some sketch. Okay, you have some, at least you have some sketch. Tetapi ya, you understand? I explain tadi kan. You need to be exact lah. The size, overall size kan. You show okay. At least now you have the structure lah. Can you rearrange
Can.
yang saya nak ni? Exactly the location. You have casing macam you have a box kan. Ribbon blender tu kan. Okay, the box is the casing. Tetapi the box is it a box or kind like maybe they have some curve ke apa, macam saya ni ada curve ke?
Yeah.
Tak
Yes.
nampak tak estetik. Saya nampak as kotak je kan. Dia kind
Maybe
like pasal you ribbon blender kan you punya overall size is circle kan. Side view is circle kan, ribbon kan. It's a circle kan. So I think why do your casing must be box? So kalau dia more tu kan, dia more ikut the profile of you punya blender tu. That's how define you punya casing shape. Understand me? It should be like this. Modify balik lah.
Okay.
Modify it should be macam ni kan. You ribbon pun you look on the side view pun it's a circle kan. Just spiral lah. It's a spiral kan.
Yeah.
So it should be like this. The container, the casing, the container for your blender. Huh? Should be like this.
Okay. Understood.
Takkanlah
Because
box
I
gitu lah.
I just do the rough sketching only.
Okay, one thing, okay, this is your sketching. You have all these you punya component. Okay, you need to be, tu lah cakap, do what I ask you to do like this. First, you identify the zone. Pasal ini you just simply motor. Tetapi exactly tu lah. You buat zone, power unit, transmission unit. Okay, can you redo it this again? Okay, the
Alright.
sketching. Okay, ikut yang what I ask you to do. Then you put the exact location, the size, overall size. What is the size of your container of your blender tu? Is blender considered mixing kan? Blender is mixing blender lah, blender For what is it? Blender apa tadi? Blender apa? Cereal
Ribbon blender to make the instant breakfast cereals.
Benda ni ada in the market kan? Nanti dulu, hold on jap.
Yes. I got found the seller sell this machine.
Oh, kenapa sorry lah saya mention apa significant of this product
Significant. What do you mean?
Sorry lah to ask you. Kita kan just put the cereal in the bowl and we pour milk then we makan lah. Kenapa? Kenapa we nak mix? Kenapa kita nak mix cereal? Breakfast cereal? Why do we need machine? My question.
I think it's mixed from the raw materials and the product is instant breakfast cereals.
Oh, raw material dia apa? What is the raw material?
I'm not sure.
Itulah saya cakap how many of you? 4 of you kan?
Yeah.
So that's why you have to make an effort you have to be exact. You cannot simply design machine. We just think, why not winner? No, be careful about that. We have to really, is there in the market? Why? Okay, you said market kan? Okay, you said, benda ni memang is there in the market, right? Am I right? Instant breakfast cereal blender. What you call it machine? Okay, tell me frankly, is this you just design yourself or you just assume it in market or is it really in the market?
It really
What is
in
it
the
called?
market. A ribbon blender.
Ribbon blender for cereal.
Yeah.
Okay, so what is the raw material dia punya? So you have to make research. What is the raw material? Kalau the raw material is just you buy cereal box and you just pour in your bowl and you make, I cannot see what is the so important about this machine.
Oh, okay, understood.
Okay, you mean raw material tu? What is the it blend? It become what? Do you? Okay, we are not talking about make, right? Just to make to blend a cereal.
Yeah.
Okay. To mix, you check balik to do what? Is it to do, okay, in cereal we have sometimes they have corn punya chips and they have fruits and they have some what we call it more like high fiber punya component like fruits. They put some what we call it yang berkhasiat lah, punya content, high fiber, fruits, chips. Is that the purpose? They need to mix to equally uniformly distribute or what? So you got to check now, you got to check.
Okay.
Because we need to make sure what we are going to blend, we're going to mix. That will define nanti what is the RPM of your machine, what type of blade. Okay, you said it's spiral and ribbon kan? Using ribbon. Okay, kalau ribbon tu lah tengok ribbon pun, okay, what's the output speed?
The output speed is 46 RPM.
Okay. Actually, can you explain to me again apa actually dia nak mix benda ni?
The product it makes will be the instant breakfast cereals, but I'm not sure the raw materials. I need to check back again.
Oh, okay. To make sure. Is it they are pouring the commercial cereal we buy in the market
No.
and we pour it inside? No need. But to me, it's not. Itulah, benda tu not necessarily this machine, right? Betul kan?
I
It's
think
already raw material. So yeah,
yeah.
it should be
Those-
raw material, right? So to do what?
Yeah.
So you have to know. You not simply okay. You want to do. You have to know exactly what it is because it will define what type. Okay, the raw material will be poured inside the container. So what it kind like we know. Okay. If you say the standard missing blade is a ribbon, right? What you call ribbon? Is it spiral? I just assume spiral. Ribbon is spiral,
Yes.
Spiral or
Spiral.
ribbon? Yeah, spiral lah. Spiral is ribbon lah. So
Yeah.
you punya blade tu yang student C nanti, you ada student A on power unit, student B on the middle shaft, on the shaft C. Okay, you are using gears, right? Instead of, okay, you have a combination of V-belt and gears. Why?
Because the machine need to use in very very accurately and precision. So
Okay,
and the distance, because the gear distance is limited, so we use V-belt, and then we for the precision speed we use the gear. So there's a combination of V-belt and gear.
Okay, so you need to justify it in your report. So sekarang ni I see you punya machine, everything is floating in the air. That's why kalau you follow the order I say to do, so you do exactly. Do correction on that. You need to be exact what you punya supporting structure, the location, everything is plotting. I see right now. Okay, I understand your machine, but everything is plotting. I don't know the size exactly, the location. Okay. At the end, I need to see also the shaft length, the location of the bearing, exactly what location of the shaft.
Okay.
Motor is floating. The V-belt is floating. The V-belt is mounting on the shaft of the motor. Okay, shaft of the motor, is it can you see the small pulley of your V-belt? You directly mounted on the motor? You mean the small pulley? Yeah, it's mounted. It's mount on the motor shaft. Is it mount on the motor shaft?
Yes.
Can you point me? Can you share me in the internet? Okay, can you share me in the internet what motor? Ada gambar motor you use? I need to see this shaft of the motor. If not the case, if shaft of the motor is so short, that's why you need a coupler, like as I mentioned just now, for shaft A. You understand that?
There's a coupler use. I didn't draw it.
Yeah, ada coupler. There will be shaft A, right? At the small pulley, kan? Small
Yeah.
pulley. Shaft A, that one shaft A. It's not shaft motor, Motor shaft drive the coupler, Coupler connected to the motor. Okay. Alright, shaft A to student A doing the analysis. Tapi be careful lah, you have to detail sketching and location, and not everything must be spotting by members. It's not floating.
Okay.
Kena make sense lah benda ni. It's not floating. It's not floating. You punya casing tu, ribbon punya casing tu, mesti ada structure lah. You kena draw lah dia. Tengok sini. You kena prepare. You kena ada supporting structure macam ni lah. This is your punya mixer unit. This will be the zone of your ni lah kan. At the end mula-mula you sketch macam ni. You punya power unit, transmission unit, you prepare the zone. So I believe, okay, ni you punya zone macam ni. Ni power unit. Power unit is here lah. The one that I agree, you punya transmission unit yang ni, this zone.
Okay, understood, Doctor.
You design, you arrange lah, you punya zone mana, then ni. Okay, tapi normally kan, I have to tell you frankly kan, overall size dulu tu, itu yang you with your group member, what is dia punya, take the overall size dulu. Pasal they're quite difficult nanti nanti you focus on you punya content of your machine, then only at the end you want to, okay, this will be total our machine size. That is totally wrong tau. In design punya job, when you're using design punya project, customer you check on it. Sebenarnya you visit the industry. That's actually the case, guys. Memang you visit face to face. You visit your client that give you the project, like food industries, I don't know lah, cereal industries, cereal making industries. You visit the company. You are a design consultant. You go there, visit there. You talking to them. They give you some input. Then you visit the site and they give you. So this limitation of space lah. So they need you. This machine have to be mounted at this space, and we have to go through another production line. That's why I'm talking. It's like that's much. Create. Can you? So lah, kalau in your, I like it if you're in report lah. If you can create one of the chapter, you put kind of that kind of story. Understand that what I mean?
Yes,
Just
Doctor.
few words
Understood.
saying like that. Yeah. Macam you from customer requirement, the customer as just create the story lah. As long macam you are doing this is good. It's for your training lah.
Okay.
Overall, then you overall size first. Then you design the machine. Okay, macam some of you, macam Yijian and the group, they macam even you also you look for internet. You say they is there in the market, kan? There in the market. Okay,
Yeah.
yang tapi I'm not sure lah. You cakap there nama ni cereal mixer product. Apa tadi nama dia?
Ribbon blender.
Ribbon blender kan, ribbon blender. I'm not sure. Is it for, kalau you said for domestic use, put on the kitchen, I cannot see any dia punya significant of this product pasal kita already buy the cereal, kita pour on the bowl, make, that's it lah. I don't know. I believe this will be industry. Betul tak? They will be in the
Okay.
industry. I believe lah. I'm
Okay.
not sure. You know betul. You make a research. Create a situation is much better. You make this for industrial. It's not for domestic use. Industrial that makes cereal. You mean they pour in a raw material. Yeah, that's what I believe. You don't know that cereal is corn kan, corn chips. Normally it's pure macam Kellogg's cornflake, just corn. Normally we have another mixed with berries. Betul tak kan? Mixed with some fruit, dry fruit. Betul tak kan?
Yeah.
Mixed with something. I think that will be the raw material. I mean it will pour in the raw cornflake plus the mixed berries or something. Kan that has special kan? Remember you buy Kellogg ada yang special, more expensive, right? Yang main one is just cornflake je lah. I'm not talking about apa tu yang chocolate tu, not yang Coco Crunch, no. Coco Crunch just one thing je lah. I'm talking yang kan a special cereal yang for healthy lagi kan, ada high fiber kan, they mix with dry fruit. Itulah I believe this is industry, so they need to meet the output of your machine. They already mix that thing to be really apa, equally distribute in your container lah. Tapi I lupa nak cakap you guys. You mix output dia macam mana? How you pour it you punya ni? Even Yijian also.
Pour from
You-
the top.
Macam mana kalau you dah mix, so how do you output of your machine? You understand what I mean?
Or discharge, you mean?
Yeah, discharge. How you discharge?
The discharge valve will be put on the bottom of the machine.
Okay. You just mention. You don't have to design this thing. About all the extra component. No, there is extra thing. You don't have to calculate analysis on that. Mention in your sketching also lah, in your report. For all of you, all the group also. Of course, you punya container must have discharge, right? Mention it. In your sketching also did mention ada opening for discharge.
Okay.
Kalau tidak, tak make sense kan? Dia dah blend, how do we discharge it, right? Macam mana dia really occupy apa, limit compress space, misalnya how do you say, mesti ada opening at the bottom, right? Alright, okay. Yes, take my advice, okay?
Okay. Thank you, Doctor.
Okay, welcome. Alright, I think tak ada lagi So kalau lah, okay, so you buat lah, focus all the other group, focus on this. I need to see your sketching share me in the WhatsApp Alright, kalau tak ada apa question, ada apa question lagi tak yang lain? Group lain? Tak ada?
I think so far so good. Nanti kita balik cuba buatkan yang schematic dulu nanti Total tengok lepas tu Total komen lah. Tengok kita yang apa kurang lagi Total.
Alright, good. Okay, analysis nanti I will guide you later lah next week ni. Next week, how do you do analysis? Especially on shaft C tu. Shaft C where you have your blade tu. Itu I will help you on that. Okay. Tapi di group, different group, different situation lah. Okay, I think okay, I share you attendance. Session 8 ni. Hold on Line. Session 8. Okay, scan your attendance class. Assalamualaikum warahmatullahi.
Thank you Total.
Welcome.